want to make sure you understand the Q replication technology, how it's working, the design of it, and the components. And in particular, I'm going to talk, so the big novelty for 11.5, which was already delivered in the appliance, in the IBM data warehouse, and also the integrated analytics servers. We've already delivered this technology, and now it's available as a technical preview in 11.5. So, and the major novelty is how we replicate as a source columnar tables, CDE tables, and I will talk about this. There's a lot of the changes both to DB2 and to replication technology for handling the workloads that are specific to warehousing. Okay, that's the agenda that I've just sketched. Okay, continuous availability. This is the business we're in. And this is what we want to protect against. I refresh this chart every couple of years for the last 20 years. And unfortunately, you still find, you read the press, and I was just reading, I mean, these are, some of them are partners like Salesforce. It's not, I don't like to advertise this. IBM has had its own failures over the years, and we don't want to make the news. And actually, as a result of that, in 1998, IBM was a sponsor for the Olympic Games and the Super Bowl in 1998, and the server crashed. IBM couldn't handle the workload. And that's where we started to design the active-active solution. And the IBM.com website uses this technology, uses QRep with DB2, and hasn't been down since 2001. So that's the objective. We want to be always on, resilient, and provide continuous availability. And continuous availability not only for disasters, but for all type of outages. Oh, I'm missing a chart. Whoops. Oh, well, I'm missing a chart. The chart I'm missing is what I just said. It's not only disaster, but it's all type of outages, including maintenance and upgrades. You upgrade DB2. A lot of people will take an outage when they do that, even though you can do it without outage in some cases. What we're proposing is an active-active configuration. So an active-active configuration is 2 instances or more than 2. In the case of IBM.com, they have up to 5. That's a model that they use. So IBM is a sponsor of special events like Wimbledon, tennis, or US Open. And IBM provides the web infrastructure for that. And they use replication with 2 to 5 servers, depending on the volume they have to handle. Typically, the most common implementation use 2 sites, 2 servers, but you can use more. And these would be 2 DB2 instances that are fully independent of each other and can be at different versions, different capacity, and so on. So what we call active-active does not necessarily mean that you're updating the same table, the same row at the same time from 2 sites. In general, you have to prevent conflicts. But you certainly can run workloads on both sides. And replication is set up in both directions. So you can fail over and fail back specific application. So it's active-active. The servers don't have to be identical. They could be different versions of DB2. They could be different. That could be a DPF system. That could be a regular SMP, a regular DB2. With fewer nodes, fewer CPs, and so on, fewer tables. And you can actually replicate different tables to a different schema, and so on. But for continuous availability, typically it will be same to same, but it can be a subset of the tables that you are replicating. The technology is log capture transaction replay. So we capture changes from the database recovery log. The data is sent across the network, and it's replayed using SQL. So the replication is a software-based replication that simply uses SQL to replay transactions. So this is transaction-based replication. We replay transactions. with transaction consistency, not I move away from like replicating changes. It really is replicating transactions. Okay? Replication is typically, for continuous availability or disaster recovery purposes, is set up in both directions. So if you have a disaster and you fail over to that site, a disaster is not always like a hole in the ground where you lost everything. It could be a hardware failure. You restart the server and you want to resynchronize it. Most customers want to go back home after they failed over. So they resolve the issue and then they fall back. Or a lot of customers, what they do, every 3 months, they'll do a site switch for a regulation compliance, for example. So they have to do a drill, switch for 24 hours and come back. In some cases, they just switch data centers. They run here for 3 months, then they run back, move back and run 3 months on the other side. So we want more than disaster. So a typical configuration, particularly, so the most applications of this today are in the financial sector, banking. So a lot of banks use Q Rep today, particularly on the mainframe. A lot of banks running on the mainframe, the largest banks in the world are. And they actually replicate the entire banking transactions using Q Rep. So this will be the transactional system. And this will be a reporting system that is also used for other purposes of the data. So distributing the data to other applications so they could further do ETL process, extracting the data from the second site, as well as routing read-only queries for that site. For example, one of the banks I work with, if you go online and do banking transaction, they will go on that site. But if you ask for your transaction history for the last 3 months, it will go on the other side. Oh, this is mainframe application. Q Rep is the same on mainframe and on distributed. It's common code with the same design and infrastructure and the same interfaces. So to eliminate outage, I was running transaction on site A. I was running the green workload, which is read-only on site B. So I stop my workload, and I make sure replication has applied all the changes to site B. Typically, we can achieve sub-second latency, even across considerable distances. For example, that banking customer I'm referring to, on average, they have a 1-second latency over a distance of about 100 kilometers. And another customer have a 1.5 latency over 1,200 kilometers. So that's the kind of achievable latency between the sites. So it's the time it takes to stop, drain all your connections, and then capture all the changes that have been committed. That takes typically a second. And then you reroute the connections to the second site. So site switch can be done within a few seconds. Okay? Now, this is done for upgrades. It's not so this is a graceful switch, not a reaction to a disaster. For a disaster, you switch right away. For a graceful switch for maintenance purposes, so for example, they did this when this was on the mainframe. They did this when they upgraded the DB2 to version 12. So they could do and run it for, make sure all the applications are performing well, run there for 12 hours, and then after the application is being fully tested, you can come back. They also do application upgrades with schema changes using this kind of site switch and coming back after. So now I've been running on site B for 24 hours, perhaps using a different configuration, and I've made changes to my application. So my new application it was tested on site A. I was running the old application on site B while I was doing my maintenance, and now I just restart replicating from old to new. And now I can switch back my applications. So now I can do my maintenance on site B while the entire production is running on site A. Again, I can take my time. I still have a failover system. And then I restart replication to resynchronize after I finish upgrading site B. Okay. Okay. I keep a good pace. Interrupt me if you have a yes. That solution is not just dependent on Q Rep. It could be SQL replication. Yeah, SQL rep, the problem cannot have the same kind of latency in general, especially for higher workload. So SQL rep would be more like the 5 to 10 seconds as the workload increase. And the difference in performance between Q rep and SQL rep, Q rep is more linear. As the workload increases, we can really scale up. SQL rep tends to, well, be in a few seconds, but then when it falls behind, it can fall behind by a lot. So for this kind of application, so they both have their advantages and disadvantages, right? So that's not included in this talk, but IBM has 3 replication technology: the CDC, SQL replication, and Q replication. And I will illustrate this with a chart. So today I'm not talking about CDC. It's a different architecture altogether. But SQL replication is still used widely, and I did not include yeah. SQL replication, the difference with QRep is that SQL replication puts all the changes that it captures from the log into relational tables. So this has, if you have transformation you want to do on this table, you can actually have before and after statements. You can modify the data as you apply it, and you can put triggers on your change data table. So over the years, people have really leveraged the fact that the data is staged in DB2 relational tables, so you can massage the data before you apply it to the target. QRep was designed for performance, so you cannot modify the data in a staging area. It's using MQ for transport. I will show this in a little bit more detail. So the QRep is really capturing transaction, applying transaction as fast as possible. And you have no chance to touch that data as it's going in transit over the network, contrary to SQL replication, where it's sitting in table and you can do whatever you want. And yeah, okay. Okay, QRep. So QRep in SQL replication is it came from IBM. Basically, we worked jointly with the Almaden Research Lab in California. And basically, it's our 25th year this year. So QRep came in 2004. So yeah, just want to show. This also illustrates how we change product names every couple of years. The technology, SQL replication and Q replication, that's the constant. That's the name of the technology, but we package and rebrand every couple of years. That's the way IBM likes it. Okay, I will jump into the inners of QRep on the next chart. Okay, log capture transaction replay. This is a common technology if you want to deploy an active-active configuration. So competitors like Oracle Golden Gate will also capture the log and rebuild SQL. So this is the technology that you need for active-active configurations. So what do we have here? I have an SQL from your application. It's deleting from a table using a where clause on a column called code. And it's updating another table, and then it commits. So this is one transaction. Then this is a table, and my recovery log in yellow. So the recovery log for this transaction will have a delete statement and an update log record and an after log record, after value, before value for that log record that contained every single column with every single value. The capture program reads this, extract the actual data only from the log record that is relevant for replication. So if I have an update, I only send the before and after value for the column that has changed. I don't need to send all the columns from the data. So this is a subset, and it's binary data, and it's encoded in MQ message. We can further use MQ encryption to encrypt that message over the network. Then the apply program receives this. The metadata for QRep is all in control tables and DB2. So QRep is really a DB2 application. Then we read the message from MQ, and we rebuild SQL, which is not necessarily identical to the source. Actually, it's not. It's rebuilt based on the replication key to make sure that we update the right row. So the replication key typically will be any unique column, any unique index on the table, so primary key if you have one. And then we will rebuild clauses that say, okay, update where the customer ID is 400, and customer ID 400 is a unique value for the row, and we extracted it from the log records, and we are reusing it in the where clause of the target. Okay. Yeah, I think I'm going a little bit too slow. Yeah. Okay. So this explains the previous chart. So we read the recovery log records, extract values, put the message on MQ in compact format containing only the change columns, and then the apply program will rebuild the SQL. Yeah, that's very important to understand the limitation as well as the advantages of the technology. So what does that mean to have a technology that is based on log capture? So I think that I have a red, I'm looking for the, okay, that was a mistake. That's really bad. Okay, anyone can, okay, just say I'm short on time and then I make, there we go. Will it come back? Okay. Okay, this is important, and I want to make sure we cover the important point, because when we talk about the appliance for DB2 warehouse, QRep is positioned as a disaster recovery solution. And this technology, the primary purpose is, there's a difference between continuous availability and pure disaster recovery. I don't have charts, but disaster recovery traditionally is backup restore or disk copy. So you want make sure that if you have a disaster, you can switch your application to the failover site and have everything on the failover site that is necessary for your application to run uninterrupted. So this is pure disaster recovery. I mentioned the advantage of having like a big server, big production server, and a smaller one onto which I replicate a subset of the data for failover of that data with logical replication. So this is what we are illustrating here. So I can only replicate what is logged. So in a way, it's similar to HEDR, but HEDR replays the log in recovery, does recovery of the log. So certain operations cannot be reproduced by HEDR. So HEDR has its own limit. QRep has more limits. So in essence, QRep can capture the changes in the recovery log that can replay with SQL at the target, and it's a subset. So what we can replicate is the DML, insert, update, delete, and there's certain DDL that we do replicate. So for this solution, for example, we can support create and drop table. So you have two choices. When you do an application upgrade, for example, I was showing how some customers do this. You can run the scripts that will create your new tables and do everything manually on both sides, which is what a lot of people want to do because they want to control the upgrades. So you're creating new index, you create on both sides. You create on the second side when you're ready to do it, because you may migrate a site first, then you migrate the other side. There are changes that replication need. For example, if you add a column to a table, and if you want this column does not exist at the target, so you may want, and if you don't stop replication, you want replication to pick up the new column and then add it to the target. So we can do this. So the DDL that can be replicated is altering the data type of a column, adding a new column, and also create and drop table with all the index that belong to the table. Everything else, you have to, as part of your upgrade of your application, you have to run your script on both sides. At your leisure, though, and replication will tolerate it. And there's a difference in the change that affect replications, for example, adding a new column, from changes that are needed by your application, but replication is unaware of. For example, if I'm creating a new store procedure, replication will not create that store procedure on the other side. However, replication doesn't care, because it only cares about the change in the log. So for being able to fail over to the second site, you're going to have to create that store procedure on the second site. So common problems that people have when they fail over, it would be, for example, they created user ID, or they didn't give the proper authorities to the user ID on the second site, so when they fail over, maybe the application will fail to run because it's missing some authorities to run SQL against the database. Remember, these are two independent DB2s, so as such, they have to be administered. So that's the cost of this solution. If I do reorg and I want it on both sides, I have to do it on both sides, run stat, all the utilities and so on. If I change my storage configuration and so on. Now the advantage of that is that it allows me to stage migration and running with the old and the new system concurrently for some time. Okay? Okay. There's a couple caveats also with this technology having to do with automatic objects of DB2. So for example, sequence objects are a DB2 object that will generate values, and it's specific to each DB2, and that is also it's actually a little bit complicated. The way that DB2 generates this is not under commit semantics. So basically, I can do create sequence, order number as a begin, start with 1 increment by 2. So I'm on site A, and the application will insert into some table the next value for that sequence. So it's running on site A, so it inserts rows, so it gets 1, it gets 2, it gets 3. And this is replicated. So that table on site B has the value 1, 2, 3. However, the sequence object belongs to the database on site A. If I fail over to site B and I start running this application, it will get 1, 2, 3 again. So this is perhaps the biggest caveat with using this technology for active-active configuration. You have to deal with sequence objects. So sequence object, the traditional way that people resolve this, they will alter the values to be odd on one side and even on the other side. There's other approach to be taken also. Another approach would be to have a user exit. So before you do your site switch, you go and reset the next value to the sequence to be the maximum value used and so on. But there's only a couple caveats, but they need to be taken care of as you're planning a active-active configuration. All the tables need a unique constraint. For DB2 warehouse, it doesn't have to be enforced, and more on this later. Who's using DB2 warehouse here? Okay, a couple of people, and other people using, so DPF, no DPF, so just regular DB2. So it's more like transactional system. Part of this presentation is really stressing the difference between regular transactional system and DB2 warehouse system. And the short summary is that Q Replication technology with the enhancement that we did can handle both hybrid workloads that have both changes to row organized table and column organized table, even in the same transactions, and replicate it with the same objectives for low latency and high throughput. Even if you are ingesting 25 million rows in a single DB2 transaction, we can replicate it still within in the seconds. And I'll explain how we're doing that. Okay. So to do log capture, you need supplemental logging on your tables. So when you set up QRep or CDC or any replication oracle, same thing, supplemental logging has to be enabled. What that means is that for row organized table, every update, DB2 will log the full before and after image in the DB2 log. So the log size will increase a little bit. Okay. Okay. Q Replication design. I only have 2 charts on this, so I really want us to grasp, have a good grasp of the technology. Reading the log, replaying SQL is very important because the whole concept of what you can do and how performance is achieved needs to understand how we rebuild the SQL and the fact that we need this unique constraint to replay the changes. Okay. So QRep replaces transaction, and there's a concept of a consistency group which corresponds to one queue from the source to the target. So everything that is captured and is going on one pipe is replicated with transaction consistency. It's replayed in parallel, but preserving any dependency. So Q Replication will do dependency analysis, and if 2 transactions are not touching the same DB2 row, they will be done in parallel. So not necessarily in the same commit order as of the source, but it's okay if it's, for example, banking example, we both have a bank account with the same bank, but we have different customer ID, and customer ID is the key for that table. I put money in my account, you put money in my account. I commit first, you commit after me. But at the target, we arrive at the same time, we have nothing in common, so maybe I commit first at the target. So my latency 1 second, your latency is 2 seconds, but both data will be consistent when all the changes have been applied. So it's transaction level consistency for unrelated transactions with the dependency analysis being done at the row level. Okay, so this is the design. Everything in QRep is in DB2 tables. So what you're replicating, how replication is doing, performance metrics, everything is in control tables that are part of DB2. So when you install QRep, we create a bunch of tables in DB2 that represent the configuration for QRep. So if you're replicating some user table, you'll have one row in each, in the QRep table, the subscription table, there'll be one row for each table that is replicated. We use IBM MQ for transport and staging of the data. Now, MQ is very important for the design. So for one thing, it provides very good encryption, secure encryption across the network, as well as staging capability. So that's very important. QRep, so one difference with CDC, QRep is a completely disconnected model. So it really is a send and forget model. So the capture side leverages MQ with persistent queue to remember the change that has read from the log and sent to MQ with guaranteed delivery. So it's like certified mail from the QRep design point of view. So after a transaction has been sent, we advance the bookmark in MQ. So I know what I've sent. So now if I have a disaster, I lose site A, chances are the data has already been delivered to the target with half a second latency, depending on the distance, and the data is saved. I never have to go back to the log normally. The data will be moved. Even if you bring DB2 down at the target, the data will accumulate in MQ. And when you restart DB2, you'll apply the backlog of changes. So that's another way that we leverage MQ in the design for continuous availability. Okay. No, they don't need to be the same. So because it's just transaction replay using SQL, this can be an Oracle database. We don't care. It can be anything. And this could be DB2 version 12. This could be version 10. Actually, on ZOS, we had a customer who did a migration. They were still in Japan using DB2 ZOS version 8. They went from 8 to 12 using QRep. So that's a special thing. Yeah, that's a good question. The question is MQ included in the license. It comes with, yeah, I'm going to talk about, so we repackaged QRep. So QRep was included for free with the AESC license. And starting with version 11.5, it's a price feature. So I will talk about this. But it always includes MQ with a restricted usage for replication usage only. And this is true for both mainframe and distributed. Okay. Now, everything QRep is in tables. So who takes care of QRep typically is the DBAs, because they're very familiar with it. Even the MQ part is normally pretty trivial. MQ is just like another form of DB2, where there's order to the messages, which are like rows in the table. So now you have queues.
Do you have APIs that can manage that?
If I have APIs for what? Yeah, I'll give. Probably missing charts. Okay. Everything is in table. So how is it set up? I have like parameter tables. For example, the monitor tables every 10 seconds, that's what we recommend. We put statistics about my performance. So some customer, they can tell me what the QRep performance was 7 years ago because they back up all these tables. And they have a complete history with a 10-second granularity. What was my latency at a given time of day? How many rows I replicated and all that. It's all in the monitor table. The logs also you can find in the control tables. What is replicated? The subscription table, there's one row for each table I'm replicating. And then configuration cap parm, for example, this is where you will find in those tables above, send queues, where you find the monitor interval. So often I collect statistics and write a row into the monitor table. So basically, it's table metadata is all in tables. So the monitor table include things, for example, on MQ operation. So you'll find the Q depth, the end-to-end latency, and that's on the next chart. Some of the very important counters in those tables. So when you go to the graphical user interface, what they do in the back, they just select from DB2 tables. So they select the end-to-end latency, which is an average. So all the counters are in milliseconds. So you have like, if my monitor interval is 10 seconds, you say, OK, I replicated 80,000 rows in the last 10 seconds, and the average latency at the transaction level is like 1 second or so. OK? OK. So replication, we always like to describe, oh, I read the log, I capture the changes, I do SQL, I apply the changes. How do you start? So at the beginning, I have a database. Maybe I have nothing on the other side. And I have to create my tables and load the data. You ask a question about the interfaces. So we have a set of scripting language, which is very similar to a DB2 CLP. So it's called ASN CLP for replication. And it generates SQL statements. So I have some example of some language. For example, I'd say create a subscription for table, and I can have a pattern. So create a subscription for all the tables for this schema. So that would be one ASN CLP statement. You run the statement. You can say run now. It will go and create all that stuff, or run later, and then it will generate a file that contains all the SQL statements. So you can inspect them and then run them yourself. So what some people do, they write the script, they run it, collect the SQL, and then they can move it around. So for example, from the test to the production environment. OK. OK, initial load. The principle, and again, this is different from other technology. There's always, with IBM, and especially a product that's been out there for 15 years now, there's many ways of doing things. But the general principle of QRep is that when you load the table, you don't, obviously, you should never take an outage. So this is one of the advantages of this. You can really, for example, migrate data with zero outage. So as I'm copying my data, the big advantage of QRep is that I remember where I am in the log. So if you use a load utility, you're reading the data. As you're reading the data, it's been modified by the application. So it's a race, right? So I'm reading this row. I copy it to my target database, and maybe someone is modifying this row. But I've already read it. So QRep, by reading the logs, capture all the changes to this table as you are in the process of reading the table. So we capture the changes, and we put them in MQ. When the table is finished loading, then we apply the changes to resynchronize the table with the source. More changes are coming. So this is an ongoing thing, and I can completely clone my table without having any outage on the source. Because all the changes that happen on that table as I'm in the process of loading it will be applied by replication. And because this image here at the target is fuzzy, we will be in the force mode, upsert mode. So if I read an insert, an update, and the row is not there in the image because it did not exist when I read it from the source, then I will change the update into an insert and so on until I caught up to the time at which you started replication.
My table is 150 million rows. You have to start from row 1.
So the question is, if my table is 150 million rows, you read everything, yes. We only support full refresh. Okay, so we don't do partition level load and so on, but we do support external load. So you could do the load yourself. That's what typically, particularly on the mainframe, what people do, they use the automatic load for small table. And for example, we had one customer, they had 1,000 miles between the two sites, and the table was like 3 terabytes or something. So they killed it after 24 hours of loading. So these are challenges, right? So they use, in the end, what they did, they had like several terabyte system across 1,000 miles, and they had an infrastructure for disaster recovery that rely on XRC. So they copied all the data using a disk copy across the 1,000 miles. And that's how they initialize the database initially. And actually, one of the clients, what they do is every 3 months they have massive updates, and they have about 150 terabytes. And they have that disk copy infrastructure. So they use global mirror. I don't know if you're familiar with disk copy technology on the mainframe. But they can copy the data in about 3 hours across 1,000 miles. And basically, they have zero outage. They copy all the data, stop DB2 at the target, copy the data, restart DB2 from the disk copy, and then restart replication with a timestamp prior to the sync point when they copy the data. So you can restart replication. Well, we have the warm start. It restarts where it stopped. Or you restart with the, have to be careful. We support timestamp on the mainframe, and we'll convert it to RLSN. On distributed regular DB2, we can also restart with, actually, we don't support the timestamp on DB2, LSN. So you have to get an LSN. And for DPF, there's a problem. DPF is time-based. So it's more complicated to restart from the past with DPF. Okay. There's always a depends answer, right? Okay. So what is important here in closing with the initial load is that the load is driven from the target. And obviously, you don't have to stop your application, but you also don't have to stop replication for tables already replicating. So I'm already replicating 5,000 tables. I'm adding a new application, 10 more tables. I just define them. I can use a scripting language. It's going to update the control table. And then I start them. You start them typically, we have a signal table. So you insert cap start. So you insert a row in that special table. The capture program sees the log record for that signal table and say, oh, now I need to replicate that table too. Then it tells the other side, and then this guy creates a Q and MQ to spill the changes. So it's still replicating the other 2,000 tables. But now I have 10 more tables to replicate. So I'm going to create 10 spill Q. Actually, there's parameters to control this, how many concurrently you want to do and all that. But let's say the default, I would do 10. And all the changes are going there because these 10 tables have been loaded. Then we connect back to the source over a DRDA connection. So basically, and we do a load from select from the source. So the so-called cross-loader, I don't know if some are familiar with that term. But basically, the data is pulled from the target by the apply program. And then we apply the change. When the table is fully loaded at target, no matter how much time it takes, then it clears the backlog of changes and resynchronize the table. So as a user, I would see if I look at the tables, I would see the QRep table. The state of the subscription will be loading. Once I finish, I apply the backlog of changes, it will be active. Now I can use my table. It's synchronized within a second or so, and it's fully loaded. So I will be checking the state and the latency to know when can I start using that new table at the target.
And the spill system, the spill is a data set, right?
The spill is a MQ It's a dynamically created MQ the spill, yeah. So it'd be there. So when we finish loading the table, then we remove the queue. Okay, I'm not doing good with time, so let's see what we have. Okay, so actually this will be very quick. Now, IBM Data Warehouse. So we shipped in last year, in December of last year, for the IAS system. So this is a DPF system, designed and built. It's an appliance, designed and built for very large transaction on column organized tables. So our challenge was, how do I keep the same characteristics of QRep that I've just described in this first part for data warehouse with column organized table. So we shipped it for IBM DB2 Warehouse, which is also an appliance that you control, and for the IAS appliance. Okay. Okay, it's container-based. It's a Docker containers that include the DB2 Common Engine and QRep built. It includes MQ, QRep, and everything. But you need to buy a special license to be allowed to use QRep. So it used the console. So I don't know if some of you have attended the Unified Console, but it's based on the IBM Unified Console. This was just positioning different DR solutions for warehousing. So basically, backup restore or QRep is the main change with pros and cons to each.
Are you going to move the web console to that new data management console?
Yeah, so the question is, are we going to support replication in a new console? Yes, but there's no plan yet. So it will not be fast enough for me. Yeah. Yeah, I will get to this. The question is it the regular Q replication? So like I said, IBM likes to rebrand things very often. And there's going to be a new product offering called replication for availability. And that's what you will have to buy to enable it with that. Actually, I have a chart on this, so let me get there. So this is what I've already, I'm going to go a little bit quicker on this. I want to talk about 11.5. But this is the objectives, and this is the advantages of the technology, what is achievable. Okay. Now, this is what we shipped. So basically, you would go and enable the try and buy for 90 days. So this is the console. So you probably have seen the unified console by now. And once you enable the try and buy, which I did not show any screen shot, is you'll see the data replication under high availability. So I have database backup restore and data replication because I've enabled the 90-day try and buy, or I bought the license. So to use this, I have two machines. And I could be like using IAS replicating to a smaller box, which is DB2 warehouse. So I could have a large, shiny new machine with much more capacity, replicating a subset of my critical application to a smaller box. Actually, I could be replicating to two smaller boxes. So as I upgrade my hardware, maybe I have the older hardware that I will use for failover for a subset of business critical application. So I can failover and fall back. And I could have this in a 3-site configuration. So one machine replicating workload A for schema ABC going to machine B. And then the schema FGI going to machine C. Now, and I can independently switch these applications. So I could have the first application for these 3 DB2 schemas running on site B, and site A is still running the second application, so I can switch them back and forth. The only thing, you should not do the update to the same table at the same time from 2 sites until replication has caught up. If you do that and you do have conflicts, we'll report the conflicts, but then your data is out of sync. All you know is that a row was not applied, yeah. Okay, so you need to, consideration as you need network connection between these 2 servers with sufficient bandwidth. On the warehouse, you have a very high volume of changes. So if you want replication to respect these seconds to minute latency, you have to have, typically the best will be a private network for use of replication between the 2 systems. And then you create user ID on both systems. So I come here, I create my user IDs for replication, and the tables will belong to these users, and replication will run under that user ID. Oops. Okay, so I create a user on both sides, and then I define my network, which could be preferably a private network, so it doesn't compete for bandwidth with your application going to the same server over the public network. Okay, now what's happening now, I specify my target. So you configure QRep for the appliance to say, here's my source, here's my target. I set up the direction from A to B. Once you've done this, I will go and set up replication from B to A if I want to. I could do only one-way replication. If my goal of replication is just making the data available for some other application, maybe one direction is fine. And I would only set up one direction. So here I put the credential for connecting to the remote database. I can test my connection. And what this will do, it will actually create all the MQ objects, create the control tables for QRep, create the MQ, I create the queue manager at that point. Now I'm ready to replicate. Then I look at the schemas and the tables that I have. So I have 2 schemas here, and I have a bunch of tables. So I could do select all the tables, and then I'm going to create what we call a replication set, which is really the application that you're protecting for replication, for continuous availability purposes. So in this case, I have like 8 tables or so, and I can say, you want to load them or not? Maybe my tables already exist on the second side. I don't need to load them, or and then you will just start it. So you start replication. When you create this, it has created the MQ queues under the cover, has created MQ channels, MQ queues over your network, set up encryption. So basically, I went to 3 panels, and it created all the MQ objects, all the DB2 control tables, populated. It has changed your table to do data capture change. It has changed the DB2 parameters to have supplemental logging. I'm going to explain the parameters next. I have to hurry up a little bit. Okay, so this all under the cover with the appliance, with this Docker-based solution. Then I go to the dashboard, and I explain these monitor tables. What this does, this basically calls a REST API that will collect the data from both servers from the control table. So control table every 10 seconds, I have data about my performance, what's my latency, how long to read the log, how long across the network, how long to apply, what's my DB2 performance, how deep is my queue, and then how many rows per second I'm replicating. So this just queries DB2 table. A lot of people write their own monitors, their own dashboards, integrating performance data from QRep with their own data. For example, the bank, they would like to show how many transactions per second are running on the mainframe and what's my latency, and it's all from the same dashboard. All they do in the back is that they fetch the control tables from QRep. Okay. So this is why you want to use this. This is our plan. So we shipped the 2 appliances, the DB2 warehouse and integrated analytics servers. And 11.5 is a technical preview. So I have 10 minutes to talk about this. Okay. So how many people use QRep already? Okay, so we have like 5 or 6. So here's a little summary before I go to the summary of what is new. The product. So in the past, if you bought AEIS version of DB2, you got QRep for free with restricted usage, right? You could also buy IDR, which included both CDC and QRep under the same license and gave you everything you wanted to use. So this is still available. So you can still buy IDR, you'll get CDC and QRep. Or there's a new offering, and all the details are not worked out yet. The things I'm personally not sure yet. But basically, this will give you QRep only. I just don't know the extent of the license at this point. They haven't finalized this. But it's a version 1.2, and if you only need QRep, that's the one you would be getting. And it's a lot cheaper than the IDR. Okay, but you have to pay starting from 11.5. So you have to talk with offering management, see all the T's and I's, right? I'm not sure about what happened if you already have a SE and upgrading, what kind of upsell you have to do there. 11.1.
You said it came in AE and C.
Right.
Does it?
Yeah, it does, right, yes.
And so would that come with developers?
I'm not. Let's, after the talk, I'll point you in the right direction so I don't say anything stupid. Okay. The next 2 charts, and I don't have time to go in details. So this is a list. Again, if you're interested, something you need for the existing QRep people. The interesting thing. So, for example, for this scenario with the load, we can start with LSN. And then there's, for example, I may want to start a database with backup restore the first time around, or disk copy like I described. So you can restart with a timestamp from the past, or LSN from the past. There used to be some caveats with that. If I had multiple unique index, I could not do that. I had to drop the index and restore them. We take care of that now. We've also have added some enhancement. So during the restart, we'll take care of multiple unique index. We'll take care of foreign key constraints and so on. Okay, so that's very important. So it simplifies, greatly simplifies starting with LSN from the past when I have a fuzzy copy of my data. Load dummy on the mainframe and truncate will replicate that. So I can replicate from ZOS to LUW, ZOS to Oracle. So if you, on ZOS, to truncate all the data in the table, truncate is not efficient because it will be logged if you have data change capture on the table. So what people do, they call the load utility with a dummy input that wipes out all the data. QRep will capture this and do a truncate on the target. Okay. Multi-row insert is now available in LUW. That increased the performance of insert a lot. Okay. Performance stuff, again, I want to talk about 11.1, so 11.5. So the question, if I start replication on a single table, this one restart with LSN. I'll give you a concrete example. A customer by mistake, again, the people really know QRep here, they restart replication. Normally, you just restart warm, it starts where it was. They made a mistake, they restart cold. And then they corrupted the data of the target. And they were missing a whole bunch of transactions. So what they did, they restart with a timestamp and you resynchronize the database. So they had lost 20 minutes of data. By restarting 20 minutes in the past, they could resend everything and resynchronize everything. So that's one example of one application. The other example of this, so recovering from data corruption, just restart from the past, resend all your changes. So that's a very good use case. The other one is the initial setup, right? I do backup restore and I restart with a timestamp. Yeah. Table space level backup, probably, but then, okay, we don't have the granularity of the table level. You restart with timestamp from the past, you're going to resend everything for all the tables. It probably will work, but you're going to force all the changes that you've already applied. I think it works, yes, but it's not very, it's a big hammer for a small nail, right? Because we resend everything for all the tables in that case. Yeah, we don't have an elegant solution for the problem you're mentioning. Okay. I really have to zoom, right? So if you have anything on the next two charts, just raise your hand. Otherwise, I go to 11.5. Okay. Okay. Column organized table. Who has, that's 5 minutes, right? Who has column organized table here? Okay. 2 people. Okay. So not, okay. Maybe not so important. But this has been our last year and a half of development effort for most of the team. That's very, very good stuff and very important because I believe warehousing is IBM has a very good solution, and it was missing a replication solution for column organized table, which is really the architecture we're going for analytics type of workload. The problem is the recovery log, and if you have attended talks on 11.5 on column organized table, there's reduced logging. There's nothing useful in the logs for extracting transactions, so we had to invent our own stuff. The second thing is that they do this external table load, and they're in a single DB2 transaction in a DPF environment, they will be loading millions of rows with no commit. Now, QRep likes to see a commit, send a transaction, replay it as quickly as possible. So the solution we have for this, okay, what this says here is that this we already shipped on the appliance. But 11.5, it's not documented yet. It's a technical preview. So if you're interested to play with this, actually, we're going to have a paper that I put on the last chart. It's going to be published very soon. You can contact me to get the paper, and you can actually try this hands-on yourself. Okay? So supplemental logging on column organized table was not allowed. So there's a new environment variable at DB2. You set this up. Now it will allow you to have data change capture on the table. Data change capture, once you turn on data change capture on the column organized table, then the behavior is very different. If it's a small transaction, which is controlled by a threshold, another environment variable, we will write the full row in the recovery log records, just as if this table was a row organized table. So, and actually the threshold is very small. If I'm inserting more than 10 rows, I will not log this way. So threshold is 10. Now if I do insert row, commit, then this row will be logged as the full row and the recovery log as a diagnostic log record. So it's not used during recovery, especially for replication. If it's past this threshold, I'm doing this 5 million row insert across 10 partitions in DB2, then DB2 will write the row and supplemental logs that have nothing to do with recovery. So we will create new logs only for replication purposes. They're not backed up by DB2. They're not used for recovery. They're diagnostic, they're replication purposes. Okay, so that's what we're saying. And they're not garbage collected. Okay, so the format of the supplemental log is external table format. Okay, here's an example. So I turn on data capture change on the table, and then I delete from that table, and there were 98 rows in that table. I had 2 partitions in my database. So it will write 2 files with the row. This is a delete. The key is the first column. So the file will contain the key for all the rows that were deleted. This is for partition 1, and I have another such file containing the keys for the rows deleted on partition 2. Okay. I need to move to. Okay, that's the that's the picture you need. So I'm going to spend 2 minutes on this picture. Okay. This is Q Rep. We talked about capturing the log and sending it. The top part is the existing Q Rep prior to column organized table. So you read the log, you put MQ message with the binary data, you send it here, and then apply rebuilds SQL and applies at the target. These massive transactions for warehousing that modify 50 million rows are going to files, ET load files. Replication will take these files, send them to the target, and then the way we replay the transaction, so we invented this new concept, transaction streaming. When it's a massive transaction, we don't wait for the commit. Today, we replicate transaction. When we see the commit, we send the transaction, apply builds SQL, replay the transaction. Here, when we detect that this is a column organized table massive statement, we start streaming the transaction. As the application is inserting this 50 million rows above, DB2 starts writing files. By default, 100 meg per file. So I have all these files, and I transmit these files over a set of MQQ. Again, this is automatically generated. You don't have to be aware of this. All you have to be aware is that these files are transmitted over MQ using non-persistent queue with large messages. 100 megabytes is the maximum size. And then as soon as I receive these files, I will still do the dependency analysis and all these, but these files are for streaming transactions that I start applying at the target before they're committed at the source. So as soon as I see, oh, this is like a giant statement, I start sending the files, and here the apply and the DPF system with many partition will start collecting these files and applying them in external table loads with all the files. So with this method, if this takes 10 minutes to execute, maybe after 5 seconds I already have files ready. I transmit the files, and here I'm no more than 5 seconds behind, because I apply my rows in parallel across all the partition using all these files at the same time that the transaction is still running at the source. Once the transaction is finished, maybe I have many such statements. I commit the transaction, then we send a commit message, and the target will commit. If it's rolled back, then we roll back. So that's the principle of transaction streaming and how we replicate data for a column organized table. And ran out of time. But I think only a few people were interested in column organized table in particular, so we should meet, and I can go over these charts in more detail. So what is of concern here is since I have these supplemental logs that are not part of the archive logs of DB2, I need to understand how it's garbage collected, and more importantly, how much disk space I need for these logs. So the short answer is I should have enough logs, so if I take the target down, you want to accumulate maybe 12 hours of changes because I'm doing maintenance on my target. So if you're going to modify 5 terabytes of data in 12 hours, you need 5 terabytes of disk for replication. 1 terabyte a day. The other thing is not compressed. So maybe you need 5 terabytes of disk for replication purposes. Yeah. Any closing question? I'm sorry I ran out over time. No.
I think that if there are further questions, we can move those questions to the break.
Oh, yeah, yeah. And I mean, I'm happy, like I could introduce Q Replication to those who are not familiar with. There's these 3 charts with what's new in 11.5. So hopefully it's of value because there may be some feature that experience Q Replication we're not aware of. And then when it comes to a column organized table, since it's a technical preview, I'll be honest, I think right now with the existing code, we have about no more than 15 customers. So you'll be the first one, and we will be advocate for you directly from development. So we can really provide like first-hand assistance and helping and understanding this thing, and be like a beta customer for the 11.5, which is not officially GA yet. So 11.5 is not. The appliance is. It's the same code, but as part of being the on-prem solution, because there's no user interface, there's only ASN-CLP, so there's some caveats for using it on-prem today, and until we officially announce it as part of 11.5, which should be within a short time. Okay, any closing questions? Okay, thank you very much. Thank you.
Thanks for your presentation.
Yeah.